Hello, my name is Jim Walters. I'm a senior test engineer with Keysight Technologies, and today I'm going to be showing off one of the features of our new power analyzer, the PA2203A, which is our 4-channel model. And the feature that I'm going to be showing off today is the harmonics feature. So to show this feature off, I'm going to be providing a function generator that has two output signals that are going into our power analyzer, and these two output signals represent voltage and current. So here's our power analyzer. Right now you can see that I have a square wave going into both voltage and current, and I'm going to turn on the harmonics. And you do that by pressing the analysis button, analyze harmonics, and the bar chart. And the button there. Okay, so what you can see on this screen is the magnitude of each one of the harmonics. The blue bar shows you the measurement that you're observing, and over on the right panel is all the information about this first harmonic that's highlighted in blue. Now if you want to look at each data for the magnitude of each harmonic, we have that built in. You press the scroll harmonics button, and then you can just turn the knob over until the blue bar is highlighted. Now if you read over here on the side, it says harmonic 3, which is at 180 hertz. And then these are all the information about harmonics 3, the voltage, current, and power. So you can do that with each harmonic just by moving this out, and you can see the blue bar go out in the harmonic range. And as I moved it out there, now we're looking at the 17th harmonic, and this is all the information about the harmonics. So a lot of times when you connect up devices to electrical power, there are problems that loading the electrical power causes harmonics, and harmonics can make your system more inefficient. So this box allows you to identify where the harmonics are and then make changes to that to reduce the harmonics. I wanted to highlight the capability that we have with looking at magnitudes of harmonics. And one way to do that is we have a function generator that we could output a signal at the fundamental frequency of 60 hertz, and then I'm going to sum an additional signal that's modulated at a different frequency, some multiple of 60 hertz. So in this case, I'll feed in a 60 hertz signal, and then I'll sum it and modulate it with a 120 hertz signal with full modulation. So when we look at the magnitude bars, what we will see is a full magnitude at the first harmonic, and then at the primary harmonic, and then at the next harmonic, we'll see that it has the same amplitude because it's 100% sum frequency. So the function generators are all set up. This is what our waveform looks like. You can see a sine wave, and then this one has a 120 hertz sine wave that's modulated on top of that. That's the little bump you see there. So I'm going to turn on the analyze. And now we see our bar chart for magnitude, and you can see that the fundamental frequency is the blue bar, and then this harmonic is 120 hertz, which I have set on the function generator. So we can get information about that by scrolling over and moving till we see the blue bar. And now this is telling us that the second harmonic is at 120 hertz, and there's the voltage, 3.4 something volts. So the next thing I'm going to do is change the function generator, and I'm going to move out to the third harmonic. So I'll change this to 180 hertz. And now you can see that the magnitude bar has moved over one position. And I will scroll over to that position. And now you can see that this is saying at 180 hertz, we have the same voltage there. So I can continually keep increasing the sum frequency in multiples of 60 hertz and move the bar across. So I'm going to just do that right now, and you can watch the bar move to the right. So here's 240 hertz. The bar moves a little over to the right, and I'll jump out to 300 hertz. And now you can see the bar move further. I can scroll over to find out information about that harmonic. And now this tells you that this harmonic is out at 300 hertz, and there's all the parameters for that. So you can easily analyze your system and look at individual harmonics and check their magnitude, and there's also ability to look at phase. We'll do that at another time. So this concludes this demonstration on the harmonics, and this is a very useful feature, and it's built into our power analyzer, and I hope you get a chance to use the harmonics and gain valuable insight about your product. Thank you very much. Appreciate it. Bye.